Okay, now let's look at how we can take Bayes theorem and apply it to our data mining problem. Okay, so first we will look at an exact Bayes theorem classifier. Okay, let's assume that the target has m classes, C sub 1 through C sub m. So we have, like in the example that we saw before, these classes are C sub 1 through C sub k, and when you have a data set, you know what the classes are, then you can find the prior probabilities of the classes by looking at how many belong to C sub 1, how many belong to C sub 2, and so on, and you will have the prior probabilities of all the C's. Now the intervening event here is a predictor profile. Predictor profile is a given value for x sub 1, x sub 2 through x sub p. Right? Now you have your data, and now you group the data into each of these classes. So all the records that belong to C sub 1, all the records that belong to C sub 2, all the records that belong to C sub 3, and so on. And within each group, okay, so given C sub 1, how many of the records in this group belong to the predictor profile? So that will be your conditional probability. So in our Bayes theorem table, so we have C's here, classes, and we have the prior probabilities from the data. And when within each group you count how many predictor profiles there are, a proportion. Okay, how many are in this group, and of that how many are predictor profile A, and you get a proportion. That's your conditional probability. So now you have the prior probability and the conditional probability from the data, and then the rest is pretty mechanical. So you multiply this way, add them up, and then divide that into each joint probability. So that's what will happen here. See, you take C sub 1 through C sub k. In the case of binary target, you will have only 2 rows. Okay, and then you find how many observations belong to each of these classes, and you have the probabilities of the classes, which are prior probabilities. And then within each group, you figure out what proportion of those records are predictor profile. So you get conditional probability, and then the rest is like regular, the example that we've already discussed. So this is the formula where you get the predictor profile. So given the class times the marginal probability. So this is the joint probability of one rectangle, and divided by the sum of all the rectangles. So sum of all these joint probabilities. One joint probability divided by the sum of all probabilities. So that's what exact Bayes classifier is. Once you have the probability, and if the probability exceeds your threshold, then you will classify the predictor profile as belonging to that particular class. So here is a step-by-step procedure for applying an exact Bayes classifier. Group the records into each of the m classes, and then you find the prior probabilities of each of those. Okay, I should have included that too. And then within each group, find the conditional probability for a given predictor, and then find the joint probability, add them up, you get the probability of the predictor profile, and then divide into each of the conditional probabilities, and you get the propensity. So we will look at an example of this in Excel, where we have financial reporting data, where we have 2 predictors, company size, 2 possible values, and prior legal trouble, 2 possible values, and the classes are fraudulent or truthful. So when you have 2 predictors, each with 2 possible values, there are 4 possible predictor profiles. Company size L and prior legal trouble S, then L and no, and then S and small and S, and small and no. So there are 4 possible cases, and then for each of these cases, then we take case 1 and apply this procedure. Okay, so we'll look at this example in Excel.